Hello, this is Mrs. Brown, and today we're going to be talking about recursive formulas. So to start with, let's talk about the difference between an explicit formula and a recursive formula. I'm going to use the example of the sequence 3, 6, 9, 12. An explicit formula, you don't need the previous term in order to find the next term. So for instance, if I have the formula that goes for this sequence and I want to know the 30th term, I would just do 3 times 30 and it would be 90, and I would know the 30th term would be 90. I don't need to know what term 29 was, or the 29th term, because it doesn't depend on the previous term. A recursive formula depends on knowing the previous term in order to find the next one. So if I wanted to find the 30th term, I would need to know what the 29th term is, because I'm adding 3 each time. When you're writing recursive formulas, you're going to need to have the first term listed as well as the domain. Okay, and so let's take a look at this. We're going to focus on recursive today, but you actually will be writing some explicit formulas too. Okay. So let's take a look at an example of let's how to deal with a recursive formula. Let's say I give you a recursive formula and you're trying to find the first 5 terms of the sequence. Okay. So let's say I give you this formula. I don't know why I made that so small. Okay. This is my formula, and I tell you that the domain is greater than 2. Okay. So I have my first term, which is good because then I can use that. So I know the first term's 5, so I'm going to list my out here. In order to find the second term, I need to do 2 times whatever the first is, because this would be 2 minus 1, which would be 1, so it would be the first term in the sequence. Plus 3. This is 10 plus 3 is 13, so my next term is 13. To find the third term, I need to know the second term. So I'm going to do 2 times, and the second term was 13. So it's 1 less than the one that I'm looking for. So that's the second term, plus 3. This would be 26 plus 3 is 29. So the third term is 29. Okay. If I want to know the fourth term, I'm going to do 2 times the third term plus 3. So this is going to be 58 plus 3 is 61. So my fourth term is going to be 61. Okay. And finally, if I want a fifth term, I need to use my fourth term. So 2 times 61 plus 3. So when you multiply this out, that's going to be 122 plus 3 is 125. Okay. And so that would be the first 5 terms in this recursive formula. All right. So what are the steps to actually writing a recursive formula? Because that is something that you're going to have to do. Okay. So let's take a look at that. Okay. So a recursive formula. Okay, writing a recursive formula. So step 1, you have to figure out whether you have an arithmetic or geometric sequence. Remember, arithmetic changes, it has the same difference each time. So you're adding 3 each time or subtracting 4 each time. It's an addition subtraction kind of thing, okay? But we can find that with a difference and it will just be positive or negative. And geometric has that common ratio. So if you divide a term by the previous term, what does it come out to? Is it the same thing every single time? That means it's geometric. So your first step is just to figure out which one you have. And then you have a formula for that. So for arithmetic, you have to write a recursive formula. It's a sub n, which is the nth term, equals a to the n minus 1 plus d. And d is just that common difference. So if the difference was 5, it would just be plus 5. If the difference was, say, negative 2, you could do plus negative 2, or you could do minus 2. Either one would be equivalent. If it's geometric, okay, the nth term would be the common ratio times the n minus 1, or the previous term. So the common ratio, again, is going to be represented by r. And so if you divide a term by the previous term and each time it comes out to 6, then you would put 6 here. If when you divide it out, it's like 1/2, then you would put 1/2 there. So you're just replacing R with the common ratio. Okay, and then the final step is you have to tell the first term because you need the first term in order to do a recursive formula and the domain. Okay, so let's take a look at some examples of that. All right. So let's say I have 20, 17, 14, and 11, and I want to write a recursive formula. First step is I have to figure out whether it's arithmetic or geometric. Well, as I'm looking, if I subtract 3, I subtract 3, I subtract 3, that each time, then that would be the arithmetic sequence because it has the same difference. In other words, 17 minus 20, 14 minus 17, and 11 minus 14 all come out to minus 3. So that's my common difference. So I figured out that this is an arithmetic sequence. Okay, so then I'm going to use my formula for an arithmetic sequence. So the nth term would be the previous term plus the difference. So I substitute it in. So the nth term would be the previous term plus -3, or you could say the nth term would be the previous term minus 3. Okay, that would be an example of the recursive formula for this sequence. Your final step, you have to state the first term. So that's a sub 1, because that would be the first term in the sequence. And our first term was 20. Okay. And then the domain would be greater than or equal to 2. So in other words, the next term would be the second term or the third term and so on. We would have to have it there, and it would be an integer. That would be an example of writing a recursive formula. You need to have this or this, and you have to have this in your answer, or it's not a complete answer. So please make sure that you're including both of those pieces. Let's look at another example of this. Again, you've got to follow those same steps. If you follow the steps each time, not super scary because you have formulas to substitute stuff in, which makes it a lot easier. All right, so let's say I have this formula. First step, I've got to decide if it's arithmetic or geometric. Well, looking at it, it's jumping pretty much very quickly, so it's probably going to be geometric. If I test 500 divided by 100 is 5, 100 divided by 20 is 5, and 20 divided by 4 is 5. So I do have a common ratio, not a common difference. So I know that this is a geometric sequence. Okay, so now that I know it's a geometric sequence, I pick up the correct formula. So it's the first term, which would be the ratio, the common ratio, times the previous term. Okay, and then you just substitute in your common ratio, which we already found. Okay, and this would be my formula. But I'm not done because remember I have to state what the first term is. The first term was 4 and my domain. If I wanted to find the next term, okay, after 500, what I would do, so if I wanted term number 5, is I would substitute in 500 here and do 500 times 5, and that would give me my next term, which would be 2,500. Okay, so again, you have to have the previous term in order to find the next term. Okay. Again, and if you need to pause to write stuff down, make sure that you do so. Now that we're comfortable writing some recursive formulas, you are going to be practicing writing both. Okay, I suggest that you write down this table. So pause it and write it down because it's going to help. You have a formula for an explicit arithmetic and a recursive arithmetic. You have a formula for an explicit geometric, which we did in the previous lesson, and the recursive geometric. So if you have these down, then you'll be able to use them in order to write your formulas. Okay, it'll be a lot simpler that way. So pause, make sure you have these down, having it organized in a table like this will make it easier. So I strongly suggest that you do it that way. Okay. All right. So let's look at a couple more examples where we have to write both. Okay. So let's say I have the sequence 12, 22, 32, 42. Okay. I'm going to start with the recursive formula. Remember, I have to write both. First step is to figure out whether it's arithmetic or geometric. Well, if you're looking, the difference here, that's 10, 10, 10. So it has a common difference, which means it's arithmetic. And it's plus 10 each time. Okay. So to write the recursive, I'm going to start by writing the formula. So the nth term equals the previous term plus the common difference. So that would be plus 10 for this problem. Okay. And then my final step is to actually go in and write the first term, which would be 12, and the domain. Okay. So let's look at explicit, because I have to write both for this particular sequence. So when I look at this, my formula for arithmetic would be a sub n equals a sub 1 plus n minus 1 times d. Now, I've already found out that it's arithmetic, so I didn't have to do that step here because I already knew that, and I already know what the common difference is. So I kind of jumped into the formula, and that's okay, because if you've done this, then this one's super easy. You're just plugging stuff in the formula. Okay, so the nth term is the first term. The first term is 12, plus n minus 1 times the difference, which would be 10. I'm going to go ahead and distribute the 10. Okay, so that would be 10n minus 10. And then combining like terms, remember this is the same as plus a negative 10, which means I can then use the commutative property. 12 and negative 10 is 2. So the explicit formula for the nth term is 10 times n plus 2. Okay, and that would give me my formulas. So this is the answer, and then these two combined are the answer for recursive. But again, you need both on some of the questions, so make sure you read directions. Let's look at one more, okay? All right, so my final one, okay? Again, I'm just going to start with recursive because that's what we're talking about today. First step is to figure out whether it's arithmetic or geometric. Well, the difference here, that's 3, 6, so it's not the same difference. If I check, 24 divided by 12 is 2, 12 divided by 6 is 2, and 6 divided by 3 is 2. So therefore, this is a geometric sequence. Okay, then I can use my formula for a geometric sequence. So a sub n equals r times the previous term. Okay. My common ratio, which is what r represents, is 2. So I substitute in 2. Okay. And then this is part of my answer, but I also need to state what the first term is, which is 3, and my domain in order to have a complete answer. So I need both of those pieces. Okay. So going to explicit. The explicit is really easy to write if you've already done the recursive, because you've already figured out it's geometric, so you know what formula to use. You've already figured out the common ratio, which you need for this formula. So it's a lot simpler once you have done this part. So this is the first term times r to the n minus 1. So if I look, my first term is 3 times, and then my common ratio is 2 to the n minus 1 power. Remember, I can't multiply these two together because this has an exponent. So this is the explicit formula. You can't simplify it anymore. And that's a common mistake that people make. But since this has an exponent attached to it, you can't do 2 times 3 because of the order of operations. Exponents have to happen before multiplication. So this is the final answer, and it's as simplified as you can make it. Okay? I hope this helps. And if you have any questions, you know where to find me. Have a great day.